Blood Falls of Antarctica. Blood Falls is an outflow of an iron oxide-tainted plume of salt water, flowing from the tongue of Taylor Glacier onto the ice-covered surface of West Lake Bonny in the Taylor Valley of the McMurdoch, Dry Valleys in Victoria Land, East Antarctica. The falls with red color water were discovered by researchers in 1911, when it poured off the cliff in the Great Taylor Glacier. But question arises in everyone's mind: how is the water red in color? According to the research, the red color is a product of oxidization of iron that takes place when iron minerals dissolve in high-density salt water or brine. When this water comes in contact with oxygen, a process of oxidation ensues which imparts the bright red color. This is also the same process by which iron rusts when exposed to air. The research team used imaging from underneath the glacier using a technique called radio echo sounding or RES. This is important because saline water indicates variation and densities that were ultimately used to uncover the process of oxidation. It was found that the brine, which was from a lake that flows underneath the Great Taylor Glacier, takes 1.5 million years before finally reaching the Blood Falls. The brine is discovered to have picked up minerals from underlying hard bedrocks and gushes forth off the surface of the glacier through fissures. But the question is, can a river exist under a glacier? One might wonder how a flowing river might exist beneath the thick surface of a frozen glacier. The answer can be attributed the effects of impurities on the freezing temperature of water. Water containing soluble impurities such as salt freezes at a much lower temperature than fresh water. Moreover, frozen water contains a certain amount of latent heat that can keep the river flowing. This means that while the surface may remain frozen, the underlying brine remains liquid. It is the same principle based on which people salt streets during the winter before the onset of a storm. The brine remains liquid within the subglacial and inglacial environments, through a latent heat of freezing coupled with elevated salt content. Our findings suggest that cold glaciers could support freshwater hydrologic systems through localized warming by latent heat alone, researchers said in the study, which was published in the Journal of Glaciology. Finally, the pressure of the solid block of ice above forces water through an intricate channel of fissures which culminate in a red river that falls off Great Taylor. Another interesting insight is the presence of microbial organisms that inhabit these saline rivers with low oxygen content and survive in isolation. It can serve as evidence for adaptation in harsh environments.